This video will take you through an example of an exam-style question on standard form. And what you need to know to answer this question is what standard form is. The table gives information about the masses of the planets. Use the table to answer the questions, and we will see the table again later. And here's the questions. Part A. Jupiter is the fifth planet from the Sun and the largest planet in the solar system. It is a giant planet with a mass approximately 1,000th of that of the Sun. Find an approximate value for the mass of the Sun. Part B. Jupiter is also 317.8 times heavier than the Earth. What is the mass of the Earth? Give your answer in standard form, correct to 3 significant figures. Part C. A more accurate value for the mass of the Sun is 1.9891 times 10 to the 30 kilograms. Work out in kilograms the difference between the mass of Neptune and Jupiter combined and the mass of the Sun. Give your answer in standard form, correct to 4 significant figures. Right, let's look at these questions. Part A. Jupiter is the fifth planet from the Sun and the largest planet in the solar system. It's a giant planet with a mass approximately 1,000th of that of the Sun. Find an approximate value for the mass of the Sun. Can I suggest you stop the video here and think about your answer? Well, in questions like this, what you need to do is consider what's the important pieces of information. The first one is the mass of Jupiter, and the second one is the fact that this is 1,000th that of the Sun. So let's write down the mass of Jupiter to remind ourselves of what it is, which is 1.8986 times 10 to the 27 kilograms. And to work out the mass of the Sun, I will take this and multiply it by 1,000 because it's 1,000 times heavier than the mass of Jupiter. Now, if you had a calculator, you could put this straight through the calculator. But if not, we'll have to consider that 1,000 and see, can I put it in 10 to the power something? Well, 1,000 is 10 times 10 times 10, which is 10 cubed, 10 to the power 3. So I can rewrite this as 1.8986 times 10 to the 27 times 10 to the 3. And when I have times 10 to the power and a times 10 to the power, all I need to do to get the answer is to add the indices. So the mass of the Sun is 1.8986 times 10 to the 30 kilograms. Now in this question, we weren't asked to leave the answer to 2, 3, 4 significant figures, just an approximate answer. So I could put that as 1.9 times 10 to the 30 kilograms. Now if you have a calculator, there is a button on the calculator you can use for standard form. And it's this one here, times 10 to the x. So to enter 1.8986 times 10 to the 27, you put in the 1.8986, press this button here and put in 27. Just remember not to press the times after that 6. Or there's an extra power button. So if I want to enter 1.8986 times 10 to the 27, I'll put in 1.8986. This time I will press the times button. Then I'll press the x to the power button and I'll enter a 10 instead of the x and a 27 in the index box in the power there. So in this example, we would enter 1.8986, press the times 10 to the x button, enter 27, press the times button, enter 1,000 and press the equals, or put in 1.8986, press the times button, press the x to the power button, put in a 10 for the x and a 27 in the power, press the times button, enter 1000, press the equals, and in both cases the answer will come out to being 1.8986 times 10 to the 30, and I've put in kilograms. Let's look at part B. Jupiter is also 317.8 times heavier than the Earth. What's the mass of the Earth? Give your answer in standard form, correct to 3 significant figures. Can I suggest you stop the video here and think about your answer? Well, what are the important pieces of information here? Again, the mass of Jupiter, and this time that it's 317.8 times heavier than the Earth. So writing down the mass of Jupiter as 1.8986 times 10 to the 27. I know this is 317.8 times heavier than the Earth. So if I want the mass of the Earth, I'll take the mass of Jupiter, 1.8986 times 10 to the 27, and I will divide by 317.8. Now this is definitely a question that wants you to use your calculator. So at this point, just enter this straight through your calculator. It will come out as 5.974 times 10 to the 24. But this is 1, 2, 3, 4 significant figures. We were asked for 3, so it's 5.97 times 10 to the 24 to 3 significant figures. And that, of course, is kilograms. And part C. A more accurate value for the mass of the Sun is 1.9891 times 10 to the 30 kilograms. Work out in kilograms the difference between the mass of Neptune and Jupiter combined and the mass of the Sun. Give your answer in standard form, correct to 4 significant figures. Can I suggest you stop the video here and think about your answer? The important piece of information here, the mass of Jupiter, the mass of Neptune, and the mass of the Sun. But just before we go on, it is worth just looking at Neptune here, because the mass of Neptune is not written in standard form. In standard form, the number before the decimal point must be greater than or equal to 1, which means 1, 2, 3, etc., but less than 10. So the last number we can have is 9. And here we've got 10, so it's not in standard form. That doesn't mean we can't work with it, it's just worth noting. So let's write down these 3 masses, Jupiter, Neptune and the Sun. And the first thing is to combine the mass of Jupiter and Neptune, which is 1.8986 times 10 to the 27 plus 10.243 times 10 to the 25. Now, if we have a calculator at this point, you can put that straight through the calculator. If not, what I'll have to do is make sure the index numbers, the power of 10, is the same in both cases. And it's 27 here and 25 here. We want it to be 27 in both cases. So what we'd do is multiply by 100 to get that to 27, 10 to the 27. So I'd have to divide that one by 100 to keep it as the same number. And that comes out to being 1.8986 times 10 to the 27 plus 0.10243 times 10 to the 27. And now we have the same powers. I can just take that number and add that number, and my answer will be 2.00103 times 10 to the 27, which, as we have a lot of digits there, we'll put that as 2.001 times 10 to the 27. But now we need to take this away from the mass of the Sun. So the mass of the Sun was 1.9891 times 10 to the 30, and I'll take away my 2.001 times 10 to the 27. Again, if you have a calculator, you can put this straight through the calculator at this point. If not, we need the powers of 10 to be the same. And we've got 30 there, 27 there. I'm going to make sure they're both 30. This time I'd have to multiply by 1,000 to make that 30. So I'd better divide that one by 1,000 to give me 1.9891 times 10 to the 30. Take away 0.002001 times 10 to the 30. So now I can take that number there away from that number there, and my answer will be 1.987099 times 10 to the 30. We were asked to 4 significant figures, so to 4 significant figures, that would be 1.987 times 10 to the 30. And that's how to answer a question like this on standard form.